of the mechanoreceptors in a weight-bearing conditions. Subjects had to maintain a position with their center of foot pressure by looking at a screen which presented where their center of foot pressure was with regard to their feet position. This platform has actually some small holes, and under it there's a very precise system that allows to push a pin through the platform and with a given force to measure the sensitivity of the actual foot contact with between the pin and the foot. So basically we pushed this small pin through the platform, through the foot sole of the subject, and asked the subject if he senses anything. So we use psychophysical protocols and moving systematically the pin with greater and greater force and decreasing the force that is with which the pin is moved, asking each time the subjects to indicate if he senses something. This is an example of we measured actually whether we were loading or unloading the heel, because we initially measured the sensitivity under the heel only. So we have neutral conditions where we see the loaded versus the unloaded conditions, the frontward conditions where subjects are actually unloading the heel, and you see that there's less force, and backward conditions where subjects are actually loading the heel. So basically this only shows that the protocol of asking subjects to move the actual their weight forward or backward was actually effective. I'll skip this one. I'll come to this one. Can I go backward? Yeah. So here's the heel plantar sole sensitivity for neutral conditions, a backward and a frontward positions. So in the neutral condition, what we see is that we need a greater force for the subjects to sense that the pin is in contact with the sole of the foot. It's about 30 gram versus 20 gram when the subject is not loaded. So this is the loaded condition, and this is the unloaded conditions. This is the frontward condition here, when subjects are actually unloading the heel. There's no difference between the loaded and the unloaded conditions. That's what was expected, because the heel in the unloaded condition is actually unloaded because the weight is forward. And when the the subject is actually adopting a backward body posture, the heel is loaded, and we get about the same result than for the neutral conditions. That is an increase or decreased sensitivity when the heel is loaded. Recently, Wu and Madigan adopted a similar protocol with obese individuals, and interestingly, that's what they showed. They here have obese and non-obese individuals, and they have a similar system, manual systems, and what you see is basically for two regions, for the calcaneus and the metatarsal, you see an increased or decreased sensitivity, so an increased pressure needed for the obese to detect that a pin is in contact with the sole of their foot. So these results suggest that overweight and obesity could actually attenuate the sensibility of the plantar mechanoreceptors. So both an increased motor command variability, so an output problem, and a decreased sensitivity of the mechanoreceptors could contribute to the decreased stability we observe in obese individuals. And I'll go fast now. Just a few slides to show that this has an effect for injuries and work performance. Those are mostly epidemiological studies. For instance, there's a large study with more than 42,000 workers in the US, which shows that there's an increased risk for obese individuals. And the nature of the accidents that were reported are actually falling, lower limb fractures, articular lesions following falling incidents. The same thing with another study with 2,600 workers. BMI individuals with BMI greater than 35 had an increased work-related injuries requiring at least 1 day of absence. There's an increased likeliness of hip and wrist fracture in obese individual as well, and increased time necessary to accomplish a work-related task, which is what we basically showed with FITS task, and we believe this is mostly because of balance control problem. So that's basically the story of obese individuals and their balance control problems. So I'm open to any questions you may have.
Thank you very much, Professor. So yeah, we have time for some questions. If the people in the audience want to send some questions for Professor Tisdale, just type the question in the chat box. Sorry, I was without my headset. And well, that's it. So let's see what people want to say for you.
How long people have been obese? Well, morbid obese individuals have been obese for sometimes more than 10 years, 15 years, 20 years. And these individuals lose weight quite rapidly. We actually tested them 2 times in one of the study, 3 months after their post-surgery and about 1 year post-surgery. And obviously 3 months after the surgery, the weight loss is smaller. The increase or the benefit in balance control was smaller at 3 months than at 1 year, where they lost nearly 70 kilograms on average. Did I answer your question correctly?
Okay, so any further question?
Obviously, it's a combination of several factors. I think unipodal is a different condition. Basically, it depends of how they oscillate with respect to the base of support. It might well be a problem with a greater command that is necessary to stabilize the body because they're obese. So because of the increased motor output variability, we believe this is also a problem. But it's difficult to dissociate both the input and the output. I don't think both factors are important in explaining the stability problem of obese. So they have a greater output variability, but they also have less sensitivity at the input. And actually, we ran a study last fall with Laurence Mouchnino, who is from Marseille, and we looked actually at the sensory processes in the cortex with the EEG, and some of our data that aren't published yet suggest that sensory processes of the sensory information coming to the cortex could be a problem as well. So it's not simply force, it's not simply variability, and it's not simply sensitivity as well. It's a combination of everything. But the bad news is that training does not appear to be a solution. So from our viewpoint, the at least until now, the only solution we believe is effective in improving balance control in these individuals is basically losing weight.
Okay, so yeah, I think we don't have any additional questions, and well, I would like to thank you very much, Professor, again for the great talk. We were able to record all the talk, and we are preparing a YouTube channel that will be very quickly available online, and people will be able to join and watch your talk again if they want. And I would like also to thank all people that participate in this webinar, people from different places in Brazil and also outside of Brazil. And well, follow us in the social media and emails lists that we advise about next webinars that we are promoting. And well, that's it. I think everyone was able to follow the lecture. I want to apologize for that small issues with the connection, but I think they are not a big deal in the end. So thank you again, Professor, and it's up to you just to say goodbye for the people. And yeah, I think I thought it was a question, but that's not. Good to see you online, Melvin.
Yeah, see you, Melvin. No problem if any of you want to write directly. I don't think I provided my email, but maybe Felipe can add it somewhere.
Yeah, I'll do it right now.
Yep, thanks. Bye now.
Thank you, everybody, and have a great weekend. Goodbye.
Yep, bye.